Hi everyone. Let's take a look at the following grade 12 calculus and vectors optimization example. Find the point on the parabola x equal to y squared minus 8y plus 18 closest to negative 2, 4. Step 1. Draw a diagram. If you think about this carefully, it's going to be a parabola that opens to the right. Now, in case you're thinking I'm not connected, I don't really see that, how do we know that is the case? The first step that you can take is to complete the square. So on the side here, I'm going to take this function, x equal to, or I should say take this relation, not a function. Take this relation x equal to y squared minus 8y plus 18 and express it in vertex form, which means I'm going to write down y squared minus 8 times y. If I take this number, negative 8, and I divide this by 2, that's going to be negative 4. If I square the answer, that's going to be 16. So this means I can add, I can subtract 16, and don't forget to copy plus 18. So if you think about the trinomial, this will give you a perfect square. That's how you know you're doing it right. And this is going to give you y minus 4 quantity square plus 2. So now I can go back and I can say this function basically means go up by 4, go right by 2. There's one point of this parabola, and I'll label this as 2, 4. Now, of course, roughly speaking, it's going to be like that. That's not a perfect graph, but it's good enough for the illustration of the purpose of this question. So let's erase all this. And again, we go back, and our goal is to find a point. Let me just go back and add this back in. Our goal is to find a point closest to negative 2, 4. So if I go to negative 2 and 4, which is here, let me just go back to this color, negative 2, 4. Even without doing the calculus yet, which I will do, of course, my educated guess is right here, right there. So this appears to be the answer, 2, 4. But again, you can't just say 2, 4. You got to show the steps. And here's how you show it. So step 2, I look at this function. I'm going to find dx by dy. So I'm taking the derivative of x with respect to y. So that's going to be 2y minus 8. To find a critical point, I'm going to find the derivative, which I did, set that to 0, and I'm going to solve for y. Now here comes a little bit of mental math. I can bring negative 8 to the left, which equals to 2y. The opposite of multiplying by 2 is to divide by 2. So y is going to be 4. Now, to find the corresponding x value, I can plug it back in. And if you do that, this is going to give you x equal to 4 square minus 8 times 4 plus 18. Again, I'm going to do a little bit of mental math. That's going to be 16 minus 32 plus 18, which equals to 2. Now, even though I found this point, which equals to 2, 4, and of course I am minimizing since it's asking for the closest, you want to double check by either using the first or the second derivative test. Now, if I use the second derivative test, what that means is, and I'll grab a different color for your reference, I'm finding the second derivative. And I need to know if I find the second derivative in this case, that's going to be 2, which is a positive number, by the way. And if the second derivative is positive, it's going to be concave up, which signals to you it must be a minimum. So this circles back to the fact that we found this point, 2, 4, which must be a minimum. And of course, the last thing I'll say is if you go back to the diagram, the reason why I always say step 1, draw a diagram, is because the diagram helps you see kind of the answer before we even show all the steps. If you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.